welcome back to Chemistry 2, Unit 4. This is Lesson 4, Video 1. So in this video, we're going to start talking about theories of how reactions occur. And there's two prevalent theories that kind of work together to describe how a reaction occurs. And this first one is called the collision theory. So what this says is, for a reaction to occur, molecules or atoms or ions, whatever parts we have, must first collide. So they actually have to physically hit into each other. But the big thing here is not all collisions result in a reaction. And you might think, well, if two things are going to collide, we have a reaction. But there have to be some conditions that are met for this to occur. So this is our why. Why are not all collisions causing a reaction? Well, there's two reasons. The first reason is the reactants must have enough energy to break bonds and form new ones. So if two atoms are coming together, but they're coming together really slowly because the temperature is really low, then they might not have enough kinetic energy with their motion to cause bonds to break or to form new bonds. So we don't have a collision. The other thing, the colliding parts must be in the proper orientation when colliding. So some molecules are pretty big. So they might have a very specific shape. So if something comes in on the opposite side, it might not cause any reaction because it's not oriented in space enough. So what do we do about this? Well, we already kind of gave a clue with temperature when I said if something is not moving very quickly, well, to get it to move quicker, we could increase the temperature. So if you want to increase the number of collisions, we could increase the temperature, which would in turn increase the kinetic energy available, which increases rate of reaction. So now we have a mechanism that will explain why an increase in temperature will result in an increase in the rate of reaction. It's to increase the number of collisions. So that brings us to our second theory, and that is the transition theory. So what this states is reactants pass through a short-lived, high-energy, intermediate phase or state called the transition state. Hence the name transition theory. So if we look at this little schematic here, we have A plus a molecule B. So A plus B2. So as this starts, if these two things collide and they have enough energy and they're oriented properly, this bond here is starting to form, or actually this bond is starting to form. This bond is starting to break. So at any one given instant, as this bond is forming and this one's breaking, it's like there are partial bonds between these two, and it's short-lived. Not short-lived, short-lived. It's high energy because this is stressful, and it's in between the reactants and the products. So this right here is this transition state. And it's very unstable. And what happens is it seeks a lower energy state. So A and B together are lower in energy than having B and B together. But in order to go from this to this, we have to add enough energy to make this bond form and break this bond. And that's called activation energy. Activation energy is defined as the energy needed to reach the transition state. Or, in other words, for the reaction to start. And if you think about it, if we want something to be caught or to light something on fire, we have to provide energy in order to get that to occur. But once it starts occurring, then it proceeds through. So if I wanted to light a piece of paper on fire, I have to make sure that the temperature gets to 451 degrees Fahrenheit in order for the paper to burn. So that amount of energy that needs to be added in is activation energy. If we're already at a high temperature, we don't have to add as much. But that is the amount of energy that's needed for this reaction to begin. What catalysts do, they increase the rate of reaction by decreasing activation energy. Now, they appear not to be used up in the reaction. We're going to see that they can be, but they come back at a later time. So, enzymes are catalysts. They decrease the activation energy and increase the rate of reaction. That is what catalysts do. We'll talk about intermediates and we'll talk about inhibitors a little bit later.